Okay, let's get started. Good morning, everybody. Welcome to the joint session of PALS, MPLS, and DetNet. I'll go through the slides. So I am not Andy Malice or Stuart Bryant. I'm Dave Sinicrope. I'm usually the PALS secretary, but I'm filling in for my two esteemed colleagues because they are not here and should be sleeping, although I do see them online. We also have Nick Lehman.
Yeah, good morning, or whatever the time is in your time zone. So I'm one of the MPLS chairs. The two other chairs are also online today, and we have a MPLS session this afternoon for the MPLS topics.
Okay. So I'll run through the chair's intro slides, and you'll see that the primary reason for the session today is to discuss the MPLS network action work. But there are some other drafts, and we're going to take care of one of those initially. As soon as I figure out how to advance the slide here. Okay, there we go. So just a reminder about the note well. Take a look at that. If you have any questions, ask Secretariat. Then the meeting tips. So like I started to say just before we open the meeting, all the folks that are in person in the room today, be sure to use the MeetEcho on-site tool, the MeetEcho Lite client from Data Tracker. And then make sure that you raise your hand on MeetEcho before queuing up at the mic, because I will go by the queue in MeetEcho, not necessarily the body positions at the mic, okay? Also, if you're in the room, keep your audio and your video off. We can see you just fine, and there's cameras in the room to take care of the rest. Please wear your masks unless you're actively speaking at the microphone. Okay, remote participants, make sure your audio and video are off unless you're chairing or presenting or about to present. And we strongly recommend the use of a headset, for example, to keep background noise to a minimum. Okay. Then, as I started to say earlier, the primary purpose of the meeting is to discuss like PALS, one particular PALS draft, but primarily the joint session between PALS, MPLS, and DetNet is to go over the M&A work, substack and post-stack design, the M&A OAM, and the M&A to support deterministic latency. We also have a 30-minute open discussion at the end of the session. There are two orders of business really for that session. The first is to determine the future of the open MPLS design team, whether it will continue to meet or we revert back to normal IETF process. And the second is to discuss the drafts that were presented, time permitting. So you'll see our meeting agenda here. This is the list of the drafts. And one thing I'd like to point out is that the draft from How You Song will actually be presented by Rakesh Gandhi. And that was a last minute agenda change. Matter of fact, it happened no sooner than 20 minutes ago. So that's the only change that I've had so far. And the resources you can find at the bottom of the agenda page. And I'll hold off on the open mic until we get there. So let's see, where are we here? Okay. So with that, let's get to the first presentation. And I will bring up the wow, it seems the slides have been duplicated. The private line emulation draft. So Christian, you want to take it away from here?
Yeah, thank you, Dave. I hope everybody can hear me. Good morning, everybody. This is Christian. I would like to give you a quick update on private line emulation. It's a draft that we have been working on for a while. It was officially directed to PALS at IETF116, and I would like to show you or describe the changes we did since that happened, and we are now at the version number 3. Can we go next slide? I'm really jumping into just the changes. I don't want to take too much time. The authors from multiple vendors as well as customers have been working hard to clarify various things and improve the content. For example, we clarified the applicability with regards to CEP or RFC 4842, a TDM ish pseudowire standard from the past. We also made the definition more clear and optimized. So we now have actually 2 payload types. One is a basic payload and one is a byte-aligned payload. And the major change actually is the 4th bullet. We introduced a section called emulated services. This section actually has also been present in previous standards like RFC 4553, for example. And in this section, we clearly specify what the interface or technology specific NSP functions, the native services processing functions are, and what payload type is being used for this particular interface or technology. Why have we spent quite a lot of text in this area is because in the past TDM interfaces were single lane and fairly simple. But with the advent of multi-lane Ethernet or fiber channel interfaces, or with the advent of forward error correction being added to OTN, things are no longer as simple as a serial interface. So what we have done is basically in this section describe what to do with regards to forward error correction, what happens or what shall be done when there are uncorrectable errors, how to deal with multi-lane operation, and also the technology-specific replacement signals and downstream fault indication. We also added text now for fiber channel. So all the various fiber channel interface types are documented in addition to Ethernet, SONET SDH, and so on and so forth. We also had a discussion among the authors about large digital buffers and how to deal with them. And we have now a proposal how to expand the sequence number space to 32 bits by using both the RTP and pseudowire sequence number. And last but not least, over time, some of the referenced internet drafts also became RFC by now, and we updated that. Next slide.
So Christian, I'll hold for Sasha. We're going to hold questions till the end of the presentation. So we've got you in the queue. So long story short, the authors are confident that the draft has reached a stability and a stage where we would like to ask the working group for an option call. Maybe side notes, there is quite a lot of interest in the market space, and as well there is a first implementation from Cisco available as well. Of course, even though the draft we believe is in a very good shape, any feedback for improvements or input, of course, is welcome. Thanks for your time. Thanks, Christian. Go ahead, Sasha.
Hi, I'm Sasha Weinstein. I have a question related to the introduction of the draft. One of the examples of use cases presented there speaks about a synchronous Ethernet line between 2 customer edge devices. And the proposal is to carry the bit stream, effectively the bit stream of the character stream of Ethernet transparently. I wonder what happens with the synchronous Ethernet synchronization messages, well, if you, in this case, that carry the information about the quality of the clock quality. With the proposal as it stands, these messages would be also carried transparently. The ingress P would not actually recognize these messages and would not do anything. And the egress P would simply regenerate them as is, presenting to the remote CE and information about the clock, which may or may not be correct. I think that this should somehow be discussed in the draft. And the only thing that I have found about it that the clock, recovered clock, must address the requirements in the ITU TG 8261, which doesn't say specifies some things about clock, but it doesn't preclude a different quality of clock being used, because that's common for you have it in SDH networks, you have it in TDM networks. TDM networks are not so good about that, but in synchronous Ethernet, it's definitely present, that it is used by the receivers to select the best available clock. So I'd like to, I think that I don't have a good answer to my question, of course, and I think that this should be somehow addressed in the draft.
Yeah, thank you, Sasha. I think this is definitely something that we can discuss further, but let me maybe put my 2 cents here. What we are trying to, what we're really doing is something similar to what an optical transport network would do, right? The optical transport network would not be interfering with the Ethernet frame operation. Hence, the ESMC packets would go transparently through, like in our case as well. Of course, there's probably the concern that private line emulation over a packet network is not a connection-oriented approach. So some of the assumptions or the implicit trust of an OTN network doing with regards to the clock quality may not be present, right? I think we try to address it by describing that differential clock recovery is being used and that the quality requirements have to be met by an implementation. Now, whether we can add something more to ensure that everybody's clear about that, the network in between the 2 endpoints has to be guaranteeing the bandwidth and no loss to those packets happen. And if that is the case, then also clock recovery will work. I think we can discuss this, and I'm happy also for any input. But we feel from a generic perspective, I think the boundaries hopefully have been at least stated in the draft.
Okay, no other questions? Okay, thank you, Christian.
Thank you, guys.
One thing that I failed to mention at the beginning, note takers. If folks want to take notes, you can use the Etherpad or the HedgeDoc. I keep calling it Etherpad, sorry. The HedgeDoc facility from the agenda. I'll take notes up here and we'll amalgamate all the input that I get, both from HedgeDoc plus my own notes to produce the proceedings for the meeting. The other thing is just a note that the session is being recorded. So the next slides. Would be the OpenDT report.
David, I don't see the slide. Yeah, can you hear me? Just a confirmation.
Yeah, I can hear you. Yeah, you don't see it yet because it's not quite open yet. Hang on. I'm not sure why, but there we go.
Okay, thank
There we
you.
go.
So, thanks. This is the status update on MPLS Open Design Team activities. This is the 5th report that we've produced from the design team and shared with working groups. My name is Tariq Saad, and next slide, please. So a bit of overview about this design team before we delve into the progress. This started as a joint activity between 3 working groups, MPLS, PALS, and DetNet. And the chairs from the different working groups are coordinating agendas and decisions that we take in design meetings and outside design meetings. We have a weekly meeting that mostly we attend, and sometimes we cancel when there's no agenda, but it happens to be on Thursday, 11 a.m. Eastern. And we also, from the chairs, we meet Tuesdays as well to discuss the progress. Participation is decent. We have 15 to 20 participants every week. The last bullet has a link to the documents, the active documents that the design team is working on. So in case someone wants to take a look. Next slide, please. So since IETF 115, in terms of the working group documents and the status update on them, the first one, we have use cases for MPLS network actions, network action indicators, and MPLS ancillary data. This is at revision 2 right now. It's a working group adopted document. So we have addressed some, the authors have addressed some of the comments that the design team has produced. And at the moment, we continue, the working group and the design team continue to refine this document and keep it in line with the use cases that we want to tackle. The second document is the requirements for MPLS network action indicators and MPLS ancillary data. This is currently at revision 4. The authors have reviewed the document in light of recent adopted working group documents, and there wasn't much changes to note. At the moment, there are no outstanding issues, and this document is a working group candidate for working group last call. Next slide, please. And the next document that the design team has been working on is the framework for MPLS network actions. And it's at the moment at revision 4. So there was an update to explicitly indicate that post-stack data for MPLS network actions is an option for the solution. There are currently no outstanding issues for this document, and it's again the second document that's candidate for working group last call. And the last document is the MPLS network action substack solution. So this is a solutions document. Right now, it's at current revision is number 1, and this document has been recently adopted. We'll go over the progress on it. But there are some comments that were collected during adoption, and authors are working to address them. Next slide, please. In terms of adoption for certain documents, since last time, there were 2 working group adoption polls that were triggered by the chairs, and here's the status on those. The first one, so there was a MPLS network action substack solution. We just went over that on the previous slide. The poll went on for 3 weeks. We allowed some extension for a disclosure for an IPR. In terms of support, this document received wide support, and eventually we adopted it. There was a request to contain or constrain the solution described in this document to in-stack data for MPLS network actions and remove any references for post-stack data. We expect those to be tackled in separate documents. And the next document we have is the MPLS network actions using post-stack extension header. So this document was polled for adoption, again, for almost 3 weeks, and we allowed some extension because there was a relevant IPR to be disclosed. The poll showed minimal support and some substantial objections from the working group with regards to the IPRs filed against this document. As a conclusion, the decision was to not adopt this document. Next slide, please. So some of the open action items that are still pending, and in fact, there is a recent update on this open action item on this slide. We have a document that the design team has discussed and produced, titled IANA Registry for First Nibble Following a Label Stack. This is at revision 5 currently, and the progress on this document stalled a bit, but then the chairs had to get in and assign a new additional editor. So Greg volunteered, and thanks to Greg, to continue to drive this forward. There was a new revision for this draft, and eventually this draft got adopted. So right now it's a working group document. Next slide, please. So notable action items that we closed since last time we met. We agreed in the design team that any existing MPLS use cases, the coexistence with MPLS network action solution needs to be documented somehow. And the agreement was to add description of how these applications need to be tackled in light of M&A proposed solution in separate documents or drafts. In fact, there are some drafts that started to document these coexistence, but we expect multiple drafts to tackle this action item. And the last slide, I believe, next. So this slide, it's going to be elaborated more, and David mentioned it earlier. We have two things to talk about today is how do we want to progress on the design team meetings, the open design team meetings, and there are multiple options. Maybe there are more on David's slides as well. And the last bullet here is to we have tried to adopt a document for the solution for post-stack data. That was not successful. So right now the design
So Tarek, I think your audio is breaking up a little bit. If you could cover the last bullet again.
Sure. How is it now? Is it a little bit better? I know the internet was glitchy.
Yeah.
Okay. So the last item here is the working group and design team tried to adopt a solution for post-stack data encoding for MPLS network action. There was a proposal, but we were not successful to adopt it. At the moment, we're on the look for alternative solutions or proposals, and we continue to look for those proposals. That's it.
Okay, any questions? So in the queue, I've got Greg Mursky.
Greg Mursky, Ericsson. I realize now I have 2 points. First, without questioning their conclusion that Tarek presented on PAL for post-stack data, I recall that there were technical concerns with the proposed solution, and it was some comments from myself and from others on purely technical concern about the complexity that PSD introduces in M&A. I don't know whether they were decisive factor of not adopting the solution, but they were again expressed by several reviews. Second is my question about this last bullet, alternative solution to M&A PSD. Yes, it's true that in our framework and requirements, there is optional support of post-tech data solution for M&A. But I look at it a little bit differently. So we do have documented use cases for MPLS network actions. And I think that will be a more pragmatic approach is that to first reanalyze and look at these use cases and see if any of the use cases really requires post-tech data and cannot be reasonably addressed using existing and adopted solution for Instack data MPLS network actions. So if that will find out, yes, that we have a use case, documented a use case that we agree on to support that cannot be reasonably supported using existing and adopted by the MPLS working group solution, then I agree that we might be looking for alternative solution for PSD. But doing that out of the love for the art and just mental exercise, that might be really not using our resources and time-wise in the best way. So I think that this activity for exploring alternative solution for PSD can be supported only by existence of the case that cannot be solved by stack data. Thank you.
Okay, thank you, Greg.
Thanks,
So
Greg. Andrew?
I'll try to answer you quickly and leave room for more questions. So
Go ahead, sir.
I'm hoping that I'm still audible. Am I?
You are,
Okay,
Chair.
thanks.
Go ahead.
So indeed, Greg, there were technical points raised against the PAL document or solution, and not on purpose, I did not mention that, but the majority of the concerns were with regards to IPR PAL. On the second point of searching for alternatives for PSD, indeed, one alternative could be not to have one if we can come to agreement that we don't need one. So I think even Loa agrees with me on that, but maybe. But the one alternative is indeed if we can, prove that there is no need for it, then would be not to search or implement one. Thanks.
If I may, again, I'll be quick. So yes, I would just say not to look at this at the moment.
Okay, thanks. Okay, go ahead, Andrew. Sorry.
Hi, Andrew, Routing AD. I just wanted to put a clarification in about the objections regarding IPR, because I think it's quite important that we be fairly specific here that the objections were not around the IPR, but rather the terms of the IPR. So, because there is a difference, and I think we just need to be very clear that while a working group can object to the terms of IPR, it's not a questioning of the validity of the IPR. So, just as a clarification point there. Thanks.
Oh, thank you, Andrew, on that. I totally agree with you, and it's a glitch on our side. We should have clarified that as well.
Okay, Wei Chang?
Yeah, this is Wei Chang from China Mobile. For the alternative solutions, my understanding is that currently M&A solution is just have a basic framework, and a lot of use cases hope to use that framework to develop some solutions. So my point is that maybe this moment it's enough. So let's see if it can solve some key problems, then we decide if we need some other solutions. Thanks.
I think I am in agreement with you on the last part. We need to have that discussion and come to an agreement that it's not high priority at the moment to look for that solution. Thanks.
Yeah, Jidong from Huawei. Yeah, actually, I think we have been having a long time discussion about the ISD versus PSD, and actually each one has its pros and cons. We also have the recent mail discussion about how to deal with the multiple ISDs in the label stack. What is the impact to the existing hardwares? That question has not been answered. So I think for ISD, it is useful for specific use cases and for some specific size of data to be carried. Well, for other use cases, PSD will also be a necessary component. I think this has been reflected in the framework document. At current stage, I think both options need to be moved forward so that we have a complete solution for the M&A.
Okay, thank you, Jimmy. I think this is a good discussion to have towards the end. I think there's a slot that is dedicated for this discussion, and let's have that.
Right. Okay. Let's move on to the next. Thanks, Tara. This is a combination of the draft M&A header draft and the PS M&A header draft. So.
Hey Dave, could you hear me?
So Jack, yeah, go ahead.
Okay, yeah, thank you. Hello everyone. I'm going to give an update on our draft IETF MPLS M&A header on behalf of our authors and co-authors. Next slide, please. These are the abbreviations. Those are used in our slides. We have provided this for your references. Next slide, please. Today we will discuss about the scope of this draft and the high-level solution of the draft, which consists of network action substack header and network action LSC formats. We will also discuss some of the network action substack examples. Finally, we will discuss about the instack M&A opcodes. Those are reserved for the solution and the next step for this draft. Next slide, please. This draft discusses about the solution of M&A encoding format carried in the MPLS stack. Also, this solution addresses the M&A requirement provided in the M&A requirement document and aligns with the M&A framework document. Next slide, please. The M&A header mainly consists of two parts. The first one is M&A action substack header. A new BSPL label is labeled to indicate the presence of MPLS network action substack and the NAS encoding parameters. Next is the network action encoding format. The network action are encoded in a TLV format. That is, type is represented as the network action opcode. Length is represented as the network action length. The value is represented as an auxiliary data, which is optional. Next slide, please. This is the M&A network action substack header format. The first LSE consists of the M&A label that will be allocated for the from the BSPL label range by INA. The second LSE's TTL and DC fields are used to encode the network action substack parameters. The main parameters are IHS. This is a 2-bit value, indicate the scope of the substack. U-bit, this is the bit indicating the unknown opcode handling procedure. If this bit is set, and if there are any opcode that a node does not understand while processing the packet must be dropped. If it is not set, then skip the unknown opcode and proceed to the next opcode. Next one is the NASL. This is a 4-bit value that represents the total length of the current network action substack. Next slide, please. These are different LSC encoding used in our solution. Different LSC encodings are represented as a different formats. This would be easy to represent a specific encoding. Format A, this is the MNA label indicator used to indicate the presence of MNA substack. And format B, this is the MNA stack initial opcode encoding format. This encodes the network action substack parameters and the initial opcode. Those may need only less than or equal to 13 bits of auxiliary data. Format C, this is the MNA substack subsequent opcode encoding handling. This encodes the opcode that may require to encode more than 13 bits of auxiliary data. This consists of the opcode, auxiliary data, and the network action length. That is the length of a specific network action that is encoded. Format D, this encodes the 30 bits of auxiliary data. The auxiliary data, those could not be fit in format C, will be encoded in this format D. Next slide, please. This example shows the instack opcode. Those are encoded in the packets. Next slide, please. This slide shows how multiple network action scopes are encoded in the same packet. So this packet contains all the 3 scopes, that is ingress to egress, hop by hop, and select scope. Next slide, please. In the MNA solution, there could be a network action which may not need any auxiliary data to be carried. So to carry those kind of auxiliary network actions opcode, and instack network action opcode value 2 is reserved. So the opcode 2's auxiliary data will carry the network action bits. Similarly, like in instack opcode value 3 is reserved to carry the combination of multiple network actions that may need auxiliary data. Instack opcode 127 is reserved to extend the network action opcode values beyond 127. Next slide, please. We are addressing some of the pending comments, like whether we need the reserved opcode 3. The authors have discussed and decided to remove the opcode 3, but waiting for the chair's approval to remove it. The yearly BSPL allocation is requested for the MNA label, and your comments and feedbacks are most welcome. Thank you. I can take some questions now before going to the next slide.
Okay, thank you. Loa, you're next. Loa, do you still have a comment?
Hear me? Hello.
Yep, now we can hear you. Yep.
Okay. Okay. I have a bad echo. I got mailing list.
Okay. All right. So you'll take your question to the list. Any other questions? Okay. Let's move on to the next.
Oh, no, it's a continuation slide.
Yeah. Was it the same deck or?
It's the same deck, yes.
Oh, all right. Sorry. Let me just pop through.
Next.
There we go. Go ahead.
Okay. Now I'm going to present the new draft JAG's MPLS post-stack M&A header on behalf of our authors and co-authors. Next slide, please. These are the abbreviations. Those are used in our slide. We have provided for this for your references. Next slide, please. This is our today's agenda for this presentation. We will discuss the scope of this draft and the high-level solution of the draft, which consists of post-stack network action indicator, post-stack network action top header, and post-stack network action header. We will discuss the reserved in-stack opcode. Those are used for the post-stack network action solutions. Finally, we will discuss some post-stack network action examples and the next steps. Next slide, please. This draft discusses about the solution for M&A encoding formats carried after the MPLS stack. This solution addresses the M&A requirements provided in the M&A requirements document and aligned with the M&A framework document. Next slide, please. The post-stack M&A header mainly consists of two parts. First is the post-stack network action indicator, and the second one is the post-stack network action encoding. Next slide, please. In the in-stack M&A header, P bit is set to is reserved to identify the presence of post-stack M&A data encoded in the packet. That's how the post-stack post-stack data is identified. Encoding is identified. So the IHS scope and U bit, it's an unknown handling bit in the in-stack M&A header, are also used to indicate the scope and the unknown handling procedure for the post-stack network action. Those are encoded in the packet. Next slide, please. This is the post-stack network action top header. So this is common. This is common for all the post-stack network actions. Those are encoded in the packet. The first nibble will consist of a new value that does not overlap with the cache, control word, or IPv6 or IPv4 starting versions. The version field indicates the post-stack version, and the post-stack M&A header length field indicates the total length of the post-stack network action. Those are encoded in the packet. Next slide, please. Okay, yeah. So this is the header used to encode any specific post-stack network actions. This consists of 7-bit post-stack network M&A opcode that indicates a specific network action. Post-stack network action length indicates the total length of the auxiliary data encoded corresponding to the specific opcode. Next slide, please. In-stack opcode 1. Here the couple of in-stack opcodes are reserved to complete the post-stack solution, M&A solution. So in-stack opcode 1 is reserved to store the starting offset of the post-stack data from the MPLS bottom of stack. So this is an optional opcode. This will give the flexibility to encode post-stack data anywhere after the bottom of stack. And then in-stack opcode 4 is reserved to force a processing order across the in-stack and post-stack opcodes. Next slide, please. In this example, we show a PSD encoding. So in this example, P bit is set to indicate that the packet contains the post-stack data. The scope is set to hop by hop in the in-stack scope that represents that. The post-stack which is encoded is a hop by hop option scope. The first nibble of the post-stack data is set to 0010. Uh, uh, this has to be allocated by INR, but just for the example's sake, we made sure that this nibble is not overlapping with the cache, control word, and IPv6 and IPv4 versions. This is to support the legacy devices that may interpret the value to be control word or a cache or IPv6 or v4 version. Next one is the total length of the MNA is set to 3. It uses the three words, and the post-stack network action opcode 3 is encoded. The post-stack network action length is set to 2. That is, it contains additional 2 words of auxiliary data that is encoded for the corresponding post-stack opcode 3. Next slide, please. So here actually we are given plenty of examples. I'll just go through one. I won't go through in detail. I'm just flipping through so that you can take a look later. This example describes the instack flag-based network action opcode 2 and post-stack post-tab opcode 3 in the packet. Next slide, please. This example describes the encoding of post-stack opcode 8 and 3. Next slide, please. This slide describes the encoding of ISD opcode 2 and 3 and a post-stack opcode 3. Next slide, please. This is the network action processing in order, how actually the opcode 4 is useful. In this example, the head and intent is that the mid node should process the instack and post-stack opcode in order. That is, instack opcode 2 must be processed first, and then the post-stack opcode 3 must be processed. Then finally, it needs to process the instack opcode 8. So this encoding shows how actually the order has been preserved. The processing order should be preserved in the bit nodes. Next slide, please. This solution is made keeping in the mind that it is backward compatible, so it can coexist with cache and control word information after the bottom of stack. The solution defined here is naturally extension of extension of the instack MNA solution. It uses the similar encoding of TLV with opcode length and variable length, and reuses the scope and then U flag from the instack header. Next slide, please. So we are currently working on some of the comments from Greg, Loa, and others. We welcome your feedbacks and comments. And we would like to request for the working group adoption. Thank you.
Thank you. Any questions? Joel?
Joel Halpern from Ericsson. I'm not concerned about the format. I mean, we do need to work out if we're going to do post-stack data in exact format that everybody wants to see. You've done a reasonable job, but that's not the question. The question I have, and the question I've asked on the list, is do we need post-stack data at all? As far as I can tell, any solution to post-stack data involves significant added complexity to the processing of the instack data and of the MPLS label stack. If we really need it, okay, we pay complexity for features we need. But I haven't seen a clear demonstration of the need. And before adopting a solution, I would want to understand what problem we are solving.
Thanks. Greg?
Greg Mirsky, Ericsson. Yes, thank you for working on addressing my questions on the list. I share Joe's concern, and as I mentioned earlier in the discussion, I believe that before we start discussing technical merits of specific proposal for a post-tech data encapsulation, we need to identify that it's really required to come with one based on analysis of existing use cases. I suggest that we look at them at this use cases from the point whether there is any documented use case that cannot be reasonably solved using Instack data M&A. If we find that there is such use case that we agree that is in the scope of M&A solution that cannot be reasonably solved with our Instack data encapsulation, then we can get to discussion of and looking for post-tech data. Otherwise, I feel that we're using our time and for not the best way. Secondary, what I would point out that, and that's something that came to me that needs to be discussed in the first NIBL document that Tarek mentioned in his overview of the work, that 0010 may conflict not with assigned nibbles, but also with the SFC base header first nibble. And I will look at it in more detail and will prepare some more information for the next discussion, whether it would be MPLS working group or open design team. Thank you.
Yeah, actually, we have already a use case document where they have recorded the use cases. One of the use cases is IOM, so which needs an PSD. That's the reason, no, like we came up with this one. Thank you.
I think that is not yet conclusion of the working group that IAM really requires and cannot be solved using ISD. So I want to stress, not that it may be supported using PSD, but that it cannot be reasonably supported using ISD. And later today, I will be presenting how IAM functionality can be realized using ISD. Thank you.
Rakesh.
Rakesh Gandhi from Cisco Systems. To answer the question on why we need PSD. So it's, as Jack said, it's the IOM. IOM has multiple option types. There is pre-allocated ones, there is a direct export, there is edge to edge and whatnot. So some can be solved with Instack, I agree. But if you're doing recording of the data on every hop, there is an IOM option called pre-allocated, for example, where every node writes some timestamps and interface information and whatnot. That could be one good use case for post-tech data. Thanks.
Okay, no other questions? Okay, let's move on. Next on the list is, I believe, Greg with IOM direct export, so timely. What a coincidence.
Yeah. Okay, so we presented, I presented this at Open Design Team. We worked together, started with the MAD. Tony agreed to join in the work. He shared his comments that helped to improve the document significantly. We aligned it with their accepted by the MPLS working group in stack data encapsulation. And I would like to give you the overview of this solution and the problem that we're trying to address. Next. So as noted that in situ OEM is an example of on-path method for generating and collecting operational state and telemetry information. So it includes several optional modes that are pre-allocated incremental tracing. These modes are combining generating on a node, IEM capable node information, and collecting this information in a data packet, edge to edge and proof of transit. The RFC 9197 extended operational modes for in situ OEM by defining IEM direct export mode. So IEM direct export mode allows for generating the information and then collecting and transporting it using out-of-band methods, for example, over the management plane. But it shares the same mechanism of defining the informational elements that are expected to be collected and generated by the node. Next, please. Next slide. Okay. So this is more detailed information of IEM direct export. And it gives us opportunity, the advantages of IEM DEX, it allows for faster processing and more accurate measurements, because especially on the egress side, reading the wall clock for measurement of transit time or residence time, the time that their data packet traverses the node itself while experiencing queuing delays, which are variable by the nature. It more accurately to be measured using IEM direct export, because we disassociate taking the measurement and storing this value in the packet as the packet being transmitted. So as we know, the more accurate we can do the clock reading, the more reliable and useful information we can generate. So this is a very important benefit of IEM DEX. Next slide. So what we are proposing to use their informational elements in the format of IEM DEX header that's defined in RFC 9197, but map it into their defined in-stack data M&A. Yes, it's not exact. We are mapping because of restriction, especially because we are using label stack element format. And as you see, so we have to give bits for bottom of the stack indicator and the first bit to make a guaranteed differentiation from their based special purpose label. But this mapping is functionally sufficient for the purpose of IEM functionality using direct export option. Next slide, please. So now how this IEM DEX M&A can be used in agreed upon and accepted, adopted by the working group in stack data. So first, it can be used as M&A opcode. And again, I want to stress that IEM direct export requires use of two long words and currently 2 additional optional long word fields have been defined. So at the minimum, IEM-DEX adds 2 long words. Yes, there are some use cases. Some might be interested to use flow identifier for one long word and sequence number for another long word. Next slide, please. Also, IEM-DEX can be used with the current proposal with the network action indicator with ancillary data. It looks a little bit different, but currently the defined architecture of M&A header allows that. Next slide, please. So what are our conclusions? In the course of this work, in our discussions, we realized that currently the M&A header solution allows for 2 ways of expressing the same action. And that seems like creates unnecessary complexity. So what we're proposing for the discussion and consideration is to keep M&A opcodes and consider on eliminating network action indicator with ancillary data. So thus making only one way of expressing actions with ancillary data. 2 ways of doing the same thing to solving the same problem adds unnecessary complexity. And there are some questions about some field lengths that can be discussed further on. But we think that this draft presents the viable way of supporting the most useful IAM option. And we ask for their chairs and the working group to consider its adoption. Thank you.
Okay. We're a little bit behind on schedule, and the next draft in particular, it also deals with IOM. So I'm going to ask to hold questions until the at least the next draft is presented. So with that, Rakesh, you're up. Export data plane encapsulation for in situ OAM. There we go.
Hi, everyone.
We can have a broader discussion when we get to the open discussion into this. Yep. Thanks.
Thanks. Good morning, everyone. My name is Rakesh Gandhi, and presenting the MPLS data plane encap draft on IOM on behalf of the authors and contributors. And next slide, please. The next slide. So the agenda is look at the requirements and scope for this draft. There are some MPLS extensions defined, so we review them and the next steps. Next slide. So requirements is to carry the IOM data fields, which includes the IOM as well as the direct export data fields defined in RFC 9197 as well as 9326. The processing either on edge to edge or hop by hop or on select nodes. And using the encodings for the in-stack in the recently adopted working group document, as well as the proposal for the post-stack in JAX document. Next slide, please. So the draft has been around for about 4 years now. It's gone through multiple encoding formats. Also had completed the MPLS RT expert review, and that's when some of these M&A related ideas came out. So recently we moved the draft to use the latest in-stack and post-stack M&A encoding And that's what I'm presenting today. Next slide, please. Next one. So the in-stack encoding, as Jax presented, basically in the working group document for the M&A solution, we will use the existing fields for the unknown action encoding as well as the scope, but define a bit to say that there is a post-stack data present for IOAM. If you're using opcode 2, there is no need to have any action for flags for this one, so it can be set to 0. Next slide, please. And for the scope for IOAM, as just mentioned earlier, there are multiple option types defined. So there are edge-to-edge option types, or direct export, as well as pre-allocated, proof of transit. So in case of if you're doing end-to-end, there are a couple of option types that's carried, and scope is set to I2E. And then intermediate nodes would just ignore those options. In case of hop by hop, the pre-allocated and proof of transit option types, as well as direct export option types, are carried in this case. I think we are suggesting to not support the incremental option type, just like IPv6 case. I think when people worked on IOM for IPv6 case, they said, let's not do incremental. So we said, let's do the same for MPLS as well and not worry about it. And in case of select, it's almost same as hop by hop, except the scope is set to select nodes, and only the select nodes will process them. Next slide, please. So if you look at the encoding from Jack's draft for post-stack, basically there is a first nibble. I think it can be allocated by IANA, or we can reuse the existing one. We prefer the IANA allocated one for post-stack to avoid any backwards compatibility issue. Again, the option types is carried. Those are the coming from the couple of RFCs for IOM and direct export here, and the length and whatnot is added. So this is all in post-stack. Next slide, please. So if you need to carry multiple option types, so if you have a use cases like you're doing hop by hop tracking of path, or doing end-to-end latency measurements and things like that, you can put multiple post-stack network actions with the opcode for IOAM. And the option types are already defined in the 2 RFCs, and this also includes the direct export as well. And the rest just follows the normal IOM processing for the data field. Next slide, please. So this is just an example of hop by hop and I2E, including the M&A. So in this case, as M&A solution is defined, we have 2 M&A substacks, one for each scope. So in this case, we would have 2 M&A substacks. And another key point is that if you're doing hop by hop processing, the hop by hop IOM is put ahead of the end-to-end, so that you don't have to have deep packet read or write. Next slide, please. So there is this is a discussion on the direct export. Greg presented one draft on it. The solution defined in this draft is for post-stack, so that's where the direct export option type is stored. There is definitely some usefulness to have something in in-stack. There is a draft. I think we will have a presentation in a bit, which defines a telemetry trigger, just like SRv6 flag, or the alternate marking flag that's also defined in IPv6 in 9343. So we have trigger in stack, and then the option type is in the post stack with all the baggage information we can have. Next slide, please. So we welcome your comments and suggestions, and I was going to say requesting working group adoption, but I know that the post-tech draft, the encoding, the draft solution draft itself is not a working group document, so we had to wait for it. And that's all I have on this one. Comments, questions?
Any comments or questions? So let's take comments and questions for the last two drafts. Jax, go ahead.
This is for the Greg's presentation. He asked us to remove the opcode 3, which has the both the combination of M&A action bits and ancillary data. Yes, actually, we discussed with authors and then we agreed to remove the opcode 3. Thank you.
Okay, no other questions? Then I'll go back to where we are.
I'm next as well, I think.
Yeah. So we're running a little short on time, so if you can keep it to the 10 minutes. Okay. Just give me a second. There's a lot of buttons to click here. Okay, and I've also somehow turned on the audio. Okay, you've got the TWAMP segment routing.
That's right.
There we go. Okay, go ahead.
Good morning, everyone. Again, my name is Rakesh Gandhi, and presenting the draft on the enhanced PM. This is SRPM draft on using the stamp, the simple TWAMP, presenting on behalf of the authors and contributors. This is actually a draft in Spring, but there is M&A intersection, so we're presenting the work here. Next slide, please. Next one. So agenda is to look at the requirements and the scope of this draft, the summary of the solution that proposed. So SRMPLS is using M&A, and that's why we're presenting here. And there is SRV6 equivalent of the solution. And we look at the next steps. Next slide, please. So requirements is the performance measurement in SR networks. So end-to-end SR paths, including SR policies, data plane, SRMPLS, as well as SRV6. So what we're trying to do is to have no dependency on the reflector side of the TWAMP. So it's unaware of the measurement protocol. In SR, as you know, the state is in the packet. So the goal is this way we achieve a higher number of the scale, faster interval. So this is using the network programming model that's being proposed in this draft. The scope is the stamp, the TWAMP RFC 8762, and is also further extending the SRPM draft. That's a Spring Working Group document right now. Next slide, please. So just a reminder that in SRPM draft, we have 3 measurement modes defined: one-way, two-way, and loopback measurement mode. And in this draft, we're adding the network programming like SRV6 endpoint functions to enhance the loopback mode. Next slide, please. So just a recap of the loopback mode that's in the Spring draft. Basically, if in the stamp, what happens typically is that on the reflector R3, packet is punted and then re-injected to collect the timestamp T2 and T3. And in loopback mode, the packet is just forwarded like data plane on R3. So we don't get the T2 and T3. It's an optimization of punt and inject, but we're losing the one-way time, calculation of one-way time, and the only thing we get is round trip delay. So next slide, please. So what's proposed with the network programming is that in case of MPLS, we use MNA to collect the timestamp T2 in the data path. So the line rate packet forwarding on R3 not only forwards the packet, but it also adds the timestamp. So it kind of the operation of punt and re-inject and all that step is been optimized. And now we have not only the one-way delay T2 minus T1, but we also have a round-trip delay. So this is quite useful for a lot of SRPM use cases. Next slide, please. So we are using the stamp test packets. If you look at the receive timestamp in stamp, it's at 16 and 32 offsets from the start of the payload. So that's what's getting updated by the network programming. Next slide, please. Just the encoding for SR-MPLS using the network action for timestamp and forward using MNA. Basically, there is an opcode defined. It's quite straightforward for timestamp and forward. You have an offset, which timestamp to use, PTP or NTP, and we're done with it. Next slide, please. SRv6, just the equivalent, the endpoint behavior that's defined. We call it n.utsf timestamp and forward 16 or 32 is statically defined on the reflected node. Is added with the node seed in the segment list, and when it's processed by the reflector node, it will add the timestamp and forward the packet. And next slide, please. So welcome your comments and suggestions on the draft. And again, just a reminder, this is one more measurement mode on top of the SRPM draft using TWAM that already a working group document in spring. And that's all I had.
Okay, questions? Greg?
Hi, Greg Mirsky Erickson. There is some inconsistency in the first slide, that's second slide, that states that the goal is to combine session reflector being not aware of their measurement protocol at the same time to ensure their accurate one-way measurement. So their basic requirement, and you pointed out that for one-way measurement, the clocks must be synchronized.
That's right.
So basically the session reflector has to put the stamp, T2 stamp, to ensure one-way measurement. And if you are somehow using stamp for measuring two segment routes, then it should be pointing, put their T3 timestamp accurate, and then T4 stamp will help us to do two one-way measurements. Another concern that I have is how with SR-MPLS you can do guarantee for accurate round-trip measurements that will be useful, because if the packet is sent back on not co-routed path, then basically you are measuring two different paths and then you divide it by half, so it doesn't help. I can envision how it's done in SRv6, but I think that in SR-MPLS it's more of a challenge. Thank you.
Fang?
This is Fang Gao from Zhongguan Synaptory. And could you go back to the page 7? Page
sorry?
7. Page 7.
Page 7?
Yeah.
Page 7.
Yeah. Oh, yeah, this one. Maybe it's the same question which have already been raised in the mail list before. I apologize.
Can you
in advance.
get closer to the mic, because
mic.
we're having a hard time hearing? Yeah, you might need to do that.
I'm a new attending, so if it's a same question which have already raised in the mail list before, I apologize in advance. And here you use the delay by T2 minus T1, and I'm just wondering it makes sense by the reverse path. Is the SR policy or the native IP? Because you use the stamp on T3 and stamp on R1. And for the round trip, it seems what's the type of the round trip seems make no sense. And as there, it will be made some hop limitation if take the seed list or the neighbor stack of the round trip.
Yeah, no, good question. So by default, the stamp reply comes back IPUDP. Good thing with segment routing is that you can put the reverse path segment list in case of MPLS as well as SRv6 also in the packet. So it will get forwarded from R1 to R3, and then you have a segment list in case of MPLS labels bring you back to the R1. So you can ensure the co-routed path in forward and reverse direction. That's a good thing about SR.
Okay, and another question is for the if the reverse path is the native IP, and how can keep it in the fast path without pumping? What it will take some special destination inside? Yeah. Okay.
Yes. Yeah. It's a good question. So in the IPv4, IPv6 header, the destination will be set to R1.
Okay. Okay. And the last one is I'm just concerned about here, the last sentence here is the clock synchronization. I'm wondering whether it could satisfy the requirement here, as the clock synchronization normally just with the frequency synchronization. I think here needed the time synchronization with both the phase and the frequency.
Yeah, the PTP clock. So if you're using the PTP timestamps on T1 and T2, the PTP clock must be in sync between the two to do the T2 minus T1.
Okay, so it's some kind of 1588 version 2 and PTP.
Yeah, 1588 V2, exactly, yeah.
Okay, thank you.
Okay, thanks. You have about 37 seconds to do your last presentation.
Okay. I can do it.
So I will give you more than 37 seconds to do the presentation, but you keep it as short as you can.
I'll do it, yeah.
Of course, it may take me 37 seconds just to find it in here. Everything is listed twice, so I'm having to scroll through twice as many things.
Hi again. My name is Rakesh Gandhi. I'm presenting this draft on behalf of the. I'm not Hayu. He could not make it, so I'm presenting on his behalf. And there are a couple of telemetry and network actions defined in this draft. So I'll just go over them quickly. So we talked about the IOAM, the recording part. We talked about the direct export. Greg talked about direct export. What's missing is the 1 bit to trigger the telemetry or 2 bits to do the alternate marking. So SRv6 already has O bit to do this 1 bit based marking. And so we're putting a bit here and network action flag to do this telemetry trigger. There is RFC 9343, I believe, defines the IPv6 alternate marking. There are 2 bits, L and D. So we're putting the 2-bit network actions to do this loss and delay alternate marking. The 2 flags are defined in this draft. So it's basically 1 plus 2, whatever in SRv6 or IPv6 already there. They're bringing these 2 flags in MPLS. And that's basically the draft.
Okay. All right, we'll
skip
through the rest of the slides then.
Yeah.
Greg, quick.
Yes, quick. I just want to remind that MPLS working group adopted and progressing solution for synonymous labels that are useful in addition to other things for alternate marking indication.
Yeah. Thanks, Greg.
Okay, so no other questions. So then let's move on to, thanks, Rakesh.
Thank you.
That's the last one, right? You get to finally sit down? Okay. Next
Okay,
one
I'm
is Yao Lu.
attending remotely. Can you hear me? I'm attending remotely.
Right. Let me bring up your presentation
Let me
and
bring up
then
your presentation.
and you may want to shut off your speaker
may want to shut off
or turn
your
it down.
speaker or turn it down.
Okay, is it okay now?
Okay, go ahead.
Okay, go ahead.
Okay. I'm Yao from ZTE. My presentation is about signaling-based MPLS inspection MSD. Next slide. It's mentioned in the M&A framework that a node that pushes a NAS onto the label stack is responsible for determining that all nodes that should process a NAS will have the NAS within its readable label depth. And signaling is a common method to achieve this. The concept MSD is originally defined for SR, and in SR it means the maximum number of seats, and in a non-SR network, MSD defines the maximum label depth. And to fulfill the requirements from the M&A framework, this document defines a new MSD and the mechanism to signal this MSD using IGP and BGPS. Next slide. And this MSD is called base MPLS inspection MSD. And it is defined as the maximum numbers of labels the router can read in an MPLS label packet received on its incoming interfaces, starting from the top of the stack. And it can be used by the ingress LSRs to determine the position of the NAS and whether it's necessary to insert multiple NAS at different positions in the label stack. And on the other hand, with the inspection MSD, network action specified MSD like ERLD MSD may not need it further. For example, a node can signal certain network action capability, and this base PS inspection MSD to indicate that it can process this network action within the MSD. And the protocol extension is simple. A new IGP MSD type is requested, so the MSD can be advertised via ISIS and OSPF. And the IGP extensions can be advertised via BGPS as well. That's all. And welcome feedback and comments.
Any questions?
Any questions?
Okay, let's move on to the next.
Okay, let's move on to.
I'm not sure why it's doing that. I'm not sure why it's doing that. Sion, yeah.
I'm joining here. So how many minutes do I have?
You have 5.
5 minutes? Okay.
Yeah, because we still have the open session talk at the back. So ready, go.
Okay. Okay. This draft is about MPR substack encapsulation for a deterministic latency action. Okay, next slide, please. Okay, the deterministic terminology is from .NET WG. So this draft provides a solution on the deterministic latency service support using M&A. And we use .NET WG data, enhanced .NET data plane requirements draft as basis. Okay, so next slide. Yeah, okay. Based on the requirements draft, there are 4 main requirements need to satisfied. And for the number 1, number 3, and number 4, as we discussed, these 3 requirements has been certified for MPL's data plane. So, but for the second requirement to support information used by functions ensuring deterministic latency has not been certified. So the extension to the existing .NET MPL's solution is needed. Okay, so next slide. The consideration for the DLA solution. First, the indicator for the DLA is required, and then it's detailed latency information need also be carried, such as queue mechanism and its related latency information. And the information is expected to be processed hop by hop. Okay, next slide. Okay, this is encapsulation for M&A for DLA. Yes, we use M&A solution to resolve this question and use the M&A format C to encapsulate the deterministic information. And we use opcode to indicate the DLA existence, and the flag used for the queue mechanism used in the .NET network, and the NAL to identify, to indicate its length for the ancillary data. And the ancillary data will carry some detailed latency information. You know, it will depend on the queue mechanism type used in the deterministic network, and the length for the ancillary data LSE will also depend on the number of nodes in the deterministic network. So its length will be variable. Okay, next slide. Yeah, this is for the DLA queuing type, actually, which queue mechanism will be used for .NET data plane to resolve the enhanced data plane support. So we will also follow the new discussion of .NET WG. And this encapsulation for the queue is uncertain now. Yeah, and it's at its initial stage now. Okay, thank you. Next slide. Okay, for the next steps for this draft, we will make some updates on the terminology, and if there's new enhanced .NET requirements happened, we will make some updates for the consideration for DRA information, and for the MPLS encapsulation, maybe there's necessity to consider PSD solution. And for the MPLS DLA forwarding behavior, maybe we also have some consideration, make some compliments on that. Yeah, okay, thank you.
Okay, thanks. We have time for 1-2 quick questions. None. Okay, thank you, Sihan.
Okay, thank you.
Okay, this brings us to the open discussion part of the session. There are, like I said at the beginning, there are two topics that basically we need to cover here. One is, and probably the important thing to cover, is the future of the design team. Let me bring up the chair slides again. And there's a couple of slides that we put in here to walk through. Okay, here we go. Okay, so the question on the table is whether or not we should consider or whether or not we should continue the MPLS open design team meetings or calls to work on M&A, or whether we should wow, we haven't even made it past the first slide. We got a queue. Whether or not we should continue the design team calls or revert back to what would be considered normal IETF working group process with interim meetings and doing the work solely on the list and in the IETF meetings. Just there is a question on what, as we heard earlier today, there's a question on whether pro-stack data is needed, and if so, we might need to find a solution. We need to find a way to progress the work of M&A in a timely manner. And the calls and the interim meetings, whether we do formal calls as a design team or virtual meetings and between IETF meetings, that may be part of how we facilitate getting the work to progress in a timely manner. The other point to make is there are still some corporations that are interpreting the trade restrictions that exist is prohibiting informal contact, like having private telephone calls. So this was having the open design team calls or interim meeting calls is a way to get around some of those trade restrictions, or at least not circumvent them, but deal with them. So just some pros and cons quickly. Option A would be continuing the open DT calls. So the pros here are they're frequent. They're informal, flexibly scheduled between the draft authors and the working group leadership, as well as other parties. They're a way to provide quick feedback to the draft authors, potentially achieving a faster consensus. And setting up the open DT calls is far less administratively restrictive and more flexible logistically than setting up working group interim calls. Some of the downsides of continuing with the open DT calls is the authors are mostly discussing amongst themselves, amongst a subset of the community, without the wider 3 working groups worth of input. The DT really can't make any decisions without coming back to the working group. So regardless of what's discussed, they need to come back to the working group in order to ratify any decisions or ratify any proposals. Not everyone who is interested in M&A is able to make these design team calls, where that would be something that would be addressed by having working group virtual meetings. If the calls are needed to progress the work, the virtual meeting process is generally the method that the IETF asks that we use, not the continuation of or not the open design team. It's only supposed to be used on a limited basis. Option B would to progress the normal working group process. That includes both using the email lists and the meetings, as well as working group interim meeting calls. By doing this, we would presumably get wider community input. We would have, via having most or all the discussion on the email lists. The work is at the point where decisions and conclusions need to be made. There's many proposals that have been framed through the use of the design team to date. The work at this point actually needs to hone those proposals down to a few and make some decisions on which way we go forward. The decisions can be made on the calls and the email lists without a repeat or rehash of the discussion to the working group. So the idea here is even if the design team comes to consensus, the whole decision has to be rehashed on the email list or interim working group call in order, or an IETF meeting in order to actually make a decision. There was also a claim that you could get greater clarity of the decision making. There's no question as to who is making the decision in the normal working group process. It's the working group versus in the open DT calls. Some would claim that the DT made a decision, which really is not the case. But and then the important thing is that everybody can participate in these working group calls. Some of the cons for resuming the normal working group process is that the interim working group meeting process is administratively less flexible than the open DT calls. It involves a bit more overhead than scheduling the open DT calls, which puts a bit additional burden on the working group chairs and ADs and the working group secretaries. And it is likely because of the administrative burden that there will be less of, or there will be fewer of the working group interim calls. And that in turn provides less opportunity for like an open exchange of information and discussion between the interested parties. So this is just to give a few highlights of pros, cons, different viewpoints. The important thing is it's not up to the leadership to decide this. It's up to the community. So should we continue with the open DT calls or should we resume normal working group process? And that's the question on the table. So at that point, I'll open up the mic. Tony was first in the queue, then followed by Joel.
Thank you. Tony Lee, Juniper Networks. I've been participating in the open DT calls for about a year now. They have been incredibly productive. We have made a great deal of forward progress simply because we have the time, we have the bandwidth to talk to each other. It's been incredibly helpful. If we did not have the open DT, we still would be just getting started. We've probably made about 5 to 10 years worth of progress in the last year. So I strongly encourage continuing with some kind of frequent and open call. Now, how this works administratively, well, I'm not too picky about that. All I'll say is that I think that the administration and the bureaucracy should conform to optimizing the work, and the work should not conform to the sake of the administrivia. So I guess I vote for option A. Thank you.
Hello, Joel Halpern with Ericsson. I hate to disagree with Tony, but I fundamentally, strongly disagree. Not with whether the open DT did work. I could not make the calls. I therefore can't judge whether the open DT calls were useful. I can observe, however, that I couldn't make almost any of them, which was rather frustrating. More importantly, when I look at the list of things which need to be resolved now, they all are things which will need to be discussed with the working group. At this point, whether the authors agree or not is almost, not quite, they're really good people, but almost irrelevant in that we need the working group to agree on whether it wants post-stack data and if it wants it, which solution it wants. Having the authors try to negotiate bits while we're trying to figure out whether we want the bits at all is just not effective. The IETF has procedures. The OpenDT is an interesting abuse of those procedures. I'm not going to complain about it having been done, but I have real problems with it continuing.
Okay, thanks. Adrian?
Hi, I'm Adrian. I'm going to agree with Tony and Joel. How about that? Yeah, and for my next trick. So I'm completely agreeing with Tony that the design team has made great progress, and that progress would not have happened, I think, trying to drag the whole working group through. What really worries me is that the design team gives a flavor, a feeling to those of us outside of making decisions rather than making recommendations, of documenting those decisions rather than coming back to the working group and saying, we've reached this point and we need you guys to give us guidance and steerage. So, and I think the third thing then is from Joel. Yeah, it's not actually easy for everybody who cares about this work to attend those meetings, and the record of what the design team is doing and how it's progressing is maybe not coming through enough to the working group. So I think we could continue with the design team, but it's got to understand its role within the working group better and communicate better and take input better.
Sorry, I know I'm.
Other questions? So Andrew?
Yeah, sorry, didn't have my laptop open to hit the join the queue. I just want to kind of second what Adrian says, because even myself as the AD that trying to keep an eye on this stuff, it's not an option for me to be at the design team meetings because it clashes with other IESG stuff. And without that constant feedback, it actually does create a bit of a problem when you're trying to monitor what is going on in that design team. And as Joel has said, the design team does not have decision-making power. That is where the working group is. The working group makes the decisions. So that flow of communication and that decision-making power need to be very clearly sitting in the working group, because otherwise it's going to create a problem.
Loa? Loa, go ahead. Okay, Loa, we aren't hearing you. So if you are speaking, you either need to do something with your mic or maybe put your comments on the list. Okay, I'm going to move to Tarek.
I wanted to mention that Loa was having audio problems, and he was chatting with me offline. So I'm going to relay my perspective as well as his, I think. He favors the design team in trying to bring at least a recommendation forward to the working group so that the decision finally gets made within the working group. This is a process that we have been following, specifically when we want to make, a fork reach a decision-making stop. We have been engaging the working group on the mailing list and trying to converge on the decision. In here, we are presenting again a decision we want to make about the post-stack data. So I think maybe the design team has a role to play still, at least until we converge on bringing forward the recommendation to the working group. That's it from my perspective, as well as Loa's, I think.
Okay, thanks. Zafar?
Zafar, I agree with Joel. I think, and many thanks to the design team for doing a phenomenal job. But now I think we are at a stage where the inter-meeting plus the normal working group process can get the job done. Is the frequency, like there is an issue with many people to be attending all the design team meetings, even people that are interested in. So if it becomes in the normal working group process, it'd be easier and better engagement for the working group. Thanks.
G?
Yeah, Gino from Huawei. Yeah, I kind of agree with Adrian that it is more efficient to have the detailed technology discussion and analysis in the design team as a small group of people interested in this topic instead of shaking the whole working group on the mailing list, right? And I think what we can do maybe in the next step is to have timely synchronization with the working group about the recent summary or conclusion made in the design team. And we can also always provide some like a weekly or bi-weekly or monthly report to the working group mailing list, so that people who has concerns or interests, they can try to communicate with the design team or try to participate in some of the design team meetings. So that is more efficient, and we can also make use of the efforts, energy of the working group. Thanks.
Okay, thank you. Joel?
Joel Halpern from Ericsson again. The fundamental disconnect I hear here is the difference between, are design teams useful? Design teams are useful. I'd be the last person to argue that we shouldn't allow design teams. The question is this open design team thing, as it will be functioning forward, forget what it did before, a design team or the working group or some strange hybrid that bends the process out of shape? If there is a specific problem that the design team, a named set of people, can't get together by phone, Zoom, WebEx, I don't care what, and talk to each other to see if they have agreement as a design team, because some of them aren't allowed to talk, then figure out a way to put some observers in the room who aren't even participants, who are somehow making it possible for them to have the conversation, which is essentially what we're pretending to do. If that's what you need, that's a design team. I can't say you can't have a design team. That would be stupid. They're very useful things. But the working group decisions and everything I saw listed as work items for the open design team were working group decisions, need to be worked on the working group email list, or interims are only allowed to discuss things. You still need to work the result on the email list. That's where we do our work. And the fact that that may be a little slower, I'm sorry, but that's the price of doing standards.
Any other comments, questions, or views? And I'm under no misconception that we're going to come to consensus in this meeting about this problem. So we'll be taking this to the list and discussing with the chairs based on the list input. I've tried to take copious notes about what was said in the, Nick as well, what was said at the microphones. Well, with that, we have about 8 minutes left. Well, Tony, is your comment about the open design team? I was going to switch over and start taking comments and questions on the drafts.
Yes, I was going to respond to Joel.
Okay, go ahead. And then we'll switch over to the drafts.
So, Joel, you agree that design teams are a good thing, and we allow design teams to make decisions. We have to, of course, recognize that a design team's decision is not binding on the working group, and the working group has to make its own decisions. But the design team certainly has the right to make decisions about how it wants to proceed. And there's apparently a few people who are unclear on that concept, and maybe the real issue is that they need to understand that.
Okay, thanks. Any other questions or comments on the drafts? At the risk of blowing up the queue, this is where you would ask questions about the need for post-act data. Crickets, really? Okay. I guess the prior discussion has worn everybody out. All right, we will give you 6 minutes of your lives back. Thank you very much for attending, and we'll call it a day until next time. Thank you. Perfect. Perfect. That because this is usually a complete total.
Joel.